Well, ladies and gentlemen, we're going to need you to fasten your seatbelts. Your next flight could be a whole lot bumpier. From 1980 until 2008, there were a reported 234 turbulence accidents that resulted in serious injuries on U.S. airlines. But now, scientists say turbulence is becoming more common, and it's all because of climate change. So if you're like me, and you're already not necessarily into flying, maybe you hate it, I do. What can you do to brace for those mid-air jolts, and how are we being better about watching it? Joining us now, Professor of Atmospheric Science at the University of Reading, Dr. Paul Williams. Dr. Williams, thanks so much for joining us. Let's talk about what causes turbulence first.
Yeah, well, there are different causes, and the particular kind of turbulence that piques my interest as an atmospheric scientist is called clear air turbulence, and that's because it's invisible. So it's not picked up by the radar on board the plane. Satellites can't see it. It literally comes out of the blue, and it's not caused by storms. It's caused by shear in the jet stream. The jet stream is a very sheared region, and there's a lot of clear air turbulence in there.
So how does climate change factor into this? How does a warming planet create more events like this?
Yeah, well, that's the million-dollar question, and it's all got to do with wind shear. We know that climate change is increasing the amount of wind shear in the jet stream, and it's wind shear that generates clear air turbulence. And in fact, we know that the amount of wind shear in the jet stream has increased by 15% since satellites began observing it in the 1970s. And simulations tell us to expect a further 20 to 30% increase in the amount of wind shear. So this is just the wind speed increasing with altitude. So we expect a further increase by the end of this century. And what the models tell us is that we can expect maybe twice or three times as much severe clear air turbulence in the coming decades, just because of that jet stream and the shear building up in the jet stream.
From what I understand, this isn't necessarily a danger in terms of taking down a flight. They're built to withstand this, but what it is going to be a very big problem for is injuries on flights for those who aren't buckled up.
Yeah, that's exactly right. Yeah, passengers can expect to spend 2 or 3 times as much of their flight in turbulence in the coming decades. Of course, the crucial thing that everyone should do, which is, of course, what the pilots do, is to keep that seatbelt fastened when you're in your seat. That virtually guarantees that you'll be safe. The only thing that could, in theory, go wrong there is the overhead luggage bins could pop open and something could drop onto you. But that's very rare. It has happened, but it's very rare. So just keep your seatbelt fastened. And certainly there's no threat here, as far as I can see, of structural damage to planes coming from the increased turbulence.
Dr. Williams, is there any way for us to detect clear air turbulence? Is there any kind of satellite remote sensing we might be able to do in the future, or onboard equipment that might be able to sense this and help us avoid it?
It's a great question, and it's a tricky one scientifically and also from an engineering perspective, just because it's invisible. There is some technology that operates on a similar principle to a conventional radar, but it's called LiDAR, and it uses ultraviolet laser light instead of radio waves. And that particular frequency of light can be reflected by invisible density perturbations ahead of the plane. And I've seen some experiments done, some test flights, which show some pretty good promise here that we can see invisible clear air turbulence 10 to 15 miles ahead. Unfortunately, it does involve shining a laser out of the front of the plane. That could be a health and safety hazard. So there are obstacles to be overcome, I think, before we see this technology rolled out. It's also very expensive and heavy. So a lot of work to do there on an engineering perspective.
Absolutely. I understand also some of the current pilots are working on better reporting it, but still, I guess that would mean somebody's got to go through it first.
Yeah, I mean, people often ask me, how do we measure this turbulence? Because we can't see it. The satellites don't work. I mean, pretty much the only measuring equipment we have for detecting clear air turbulence at 35,000 feet is aircraft. And of course, they try to avoid it. So it is tricky to detect this kind of turbulence and measure it and get, good statistics on how frequent it is.
Well, Dr. Paul Williams, Professor of Atmospheric Science at the University of Reading. Great conversation. Thanks for being with us.
It was my pleasure. Thank you.
I had to make sure to just watch him, because that video, I was like...
Nervous flyers, that probably doesn't make you feel any better, right? Yeah. But at least he said this, you can have a good level of safety if you just keep your seatbelt on, the entire flight.
Yeah.
You're going to stay put in your seat.
Yeah, I know Chris Warren has been to like the Boeing facility. He's done that story about how these planes are built to withstand it. So it's not necessarily, you got to worry about that. But
got to worry about
if
yourself,
somebody's
not the
suitcase
plane.
is falling on your head or your coffee's on your lap, it makes for a really uncomfortable and possibly even harmful flight. You know, you don't want a broken arm after your flight, not to the beach. And what happened? Oh, somebody's suitcase
or a
fell
lap
on me.
full of hot coffee either. That's
Not
for sure.
fun.